So a distribution refers simply to the form and shape uh, of a summarized set of data, which can give us the degree of variability and quickly reveals things such as the range and the typical frequency of values associated with the sample. So if you say there's a data distribution, then you could see something like this. And typically it's in histogram form kasi kung continuous yung data, sobrang hirap. Ang ilalabas niyan sa graph is halos flat, no? Kasi kung one response for each um, definitive point of the data lang ang lalabas nun, no? So we bin them usually into arbitrarily um, set categories or ranges, sub-ranges for each. So the central limit theorem simply states that kapag lumalaki yung sample size mo, mas nag-a-approach ng normal distribution yung ating um, data. Why is normal distribution important? No, kasi especially for most parametric statistical analysis or statistical tests, the assumption would be normal yung data distribution. So, kapag hindi normal yung data distribution mo, you can only use non-parametric tests, which is usually the case for ordinal data. As a rule of thumb, it's generally good to have a number of discrete data points na greater than 30 for this to happen, and that is why, kung mapapansin ninyo, kadalasan yung mga sensory evaluation, especially for consumer tests, hindi bababa ng 30 panelists. So usually ngayon nasa 50 to 100 or more talaga, no? So this is the typical normal distribution that we could see here. Ng relevance ito is the sigma or the standard deviation in this case, no? Papansinin nyo, within plus minus 1 sigma, you have around 68% of the values. And within 2 sigma, that goes up to about 95%. And with the 3 sigma, that goes up to around 99%. So which means sa isang normal distribution, mean plus minus 3 standard deviation would most likely account for more than 99% of your data value, individual data values. So the first characteristic of a normal distribution is the symmetry, that an equal number of data points should be found either to the left or the right of the mean, and that generally for each standard deviation you should account for around the following number of points, so 68% at the first standard deviation, 95 at the second, and almost all of them within 3 standard deviations. So as you've seen below, in this case for any observation x, you can compute the z-score simply by the equation here, which is getting the difference between your observation and the mean and dividing it by the standard deviation, such that the z-score determines how many standard deviations away the observation is from the mean. Okay, so how do we use the z-table? So given here, no, yung equation mo, for any observation x that you want to know the probability of occurring, and given that you know the mean and standard deviation of your dataset, so you just compute for the z value first using this equation, inputting all of those variables, and then you look up the answer in the z table, no? For example, if you get a value of minus 3.75, halimbawa lang, so that means you're 3.75 standard deviations away from the mean. So this is minus 3.7 minus 3.7, 1, 2, 3, 4, 5. Okay, so then you have the probability here. Okay, you multiply that by 100 to get a percent value. So for example, if my z-score is minus 1.1, so ito yun, 1.1, then I have a 0.156 or 15.6% chance of getting that value from any of my respondents. You have 50 panelists evaluating the acceptability of orange juice, and you got a mean of 7.85 with a standard deviation of zero point 0.5. So we want to know what are the odds or the probability that the panelists will score give a score of 6 for the acceptability. So we use the z-value calculation, which is minus 3.7 in this case. Okay, and then we look it up sa z-table kung ano yung katumbas nun na value. So if we're gonna look at the z-table, the odds of that occurring would be 0.00011 or 0.011%. So if we're gonna see 7.85, one standard deviation is 0.5, we can see that it's 3.7 standard deviations away, or it's almost dun sa leftmost na dulo ng table. So that means given that mean and standard deviation calculated, there's a very, very low likelihood that an individual will give a response or acceptability score of 6. Okay, so that's one way of using the normal distribution. But of course, we first need to get the mean and standard deviation from our data samples, no, to be able to interpret such. So suppose instead we have 50 panelists evaluating the acceptability of orange juice still, but given the same assumption of a mean of 7.85 and the standard deviation of 0.5, we'll now look at the probability that the panelist will score at least an 8.25. So using the same equation, we first compute for the z-score, and we get the value to be 0.4 standard deviations above that of the mean. So we'll use the z-table to look it up. So take note that in this problem, no, yung sinabi sa atin is at least 8.25. So if you're going to look at the probability distribution curve, we're gonna want the area under the curve to the right of the x value in question, no? So when we look at the z-score, itong 0.4, 0.6554, yung 65.54% refers to the left side of the score, but we want the area to the right side. So to get that, we subtract this from 1, no, to get that probability, and that would give us 34.46%. Okay, so that's with the z-tables. Now you have to know, again, if you're looking at the probability of the value occurring, probability of getting something higher than that value or lower than that value. Okay. So another tool that we use is the binomial distribution, usually through the use of conveniently made binomial tables. Now, so whenever you have something due to chance, you can predict yung chances of it happening. Like, let's say a coin toss is 50% heads, 50% tails. Dice roll is 1 out of 6 chance of getting a number from 1 to 6. And usually we consider something as of not due to chance if it's marginally over that, no? Like, let's say you flip 1,000 coins, one coin 1,000 times, and you get 700 heads, no? So that is likely to be not by chance, and therefore may parang rigging yung coin mo or something like that. May meron kang pectus dun sa pagbato mo para mag-land siya on heads more often than not. Okay? So, historically, no, nung ginawa itong binomial equation, syempre gumawa sila ng mga experiments. And if you were to replicate this, so the experiment should consist of n number of trials, and a trial should be either a success or a failure. No? Like if it's rolling a dice, the probability of getting a 6, then a success would be kung 6 siya, and failure kung 1 to 5. Okay? And you are assuming that the probability of that success remains constant from trial to trial, no? Walang extrinsic factors like maybe, pag humahangin ng malakas, yung coin toss mo magbabago kasi um, may hangin, ganon. Or that repeated trials as well are independent of each other. So wala silang effect sa isa't isa. So the practical use of these are to usually in discrimination tests, if we have the triangle or duo trio test, no, you want to parang tinatanong mo yung tao, alin dito ang magkaiba or aling samples ang pareho. So obviously may tamang sagot or may success yun if you chose the sample that corresponds to either the odd one out or the one which is like the reference sample. So therefore, since you know that hypothetical probability, like if there are 3 samples, the chance of choosing the odd one out is 1 out of 3 or 33%. No? So, meron tayong tinatawag na binomial table na, for example, if you have 50 panelists doing this test na odd one out with the hypothetical chance of 1 out of 3 to get the correct answer, then it just runs the equation for each number of panelists getting the correct answer to be able to tell you ilang number of panelists yung kailangan makasagot ng tama for you to say that this was not due to chance, since if a good number of people relative to the um, chance possibility got the correct answer, so then that would mean there's something in the sample that would indicate na, uy, iba nga ito. Hindi ito yung katulad ng dalawa. Parang ganun. Okay? Okay, let's try a sample problem. Suppose we have established information that between two products A and B, the probability that product A is chosen over product B is 0.7 or 70%. Okay? So this is now your small p. And if you have 8 people testing the product, so n equals 8, what would be the probability that exactly 3 people would choose product A over product B? Okay, so that would now be your x, no? X equals 3. So ang tanong dito is that given na alam, ang expected mo talaga is that um, 70% ng mga tao ay pipili ng product A. However, if you were to test a set of 8 people 100 times, let's say, how many times would there be an outcome wherein only 3 people would choose product A over product B? Okay? So parang ganun yung ibig sabihin niya. And okay, it's simple to run through these numbers. Tatlo lang naman yung variables mo, may factorials. You can do the calculation for yourselves if you want. And the probability of it occurring is 4.67%. Similarly, if you use the binomial table, the answer that you'll get is around 4.7%. So saying if I test 8 different a set of 8 people na magkakaiba 100 times, o sige, para ma-round off na lang, 1,000 times, 47 times out of that 1,000, only 3 people will choose product A over product B. So dito mahalaga yung replicability, no? Kasi lalo na sobrang liit ng 8 tao as a sample size, no? Pag once mo lang ginawa yung isang experiment tapos sinabi mo, uy, 3 lang pumili ng A over B, I invalidate this result, yung 0.7. Pero if you were to repeat that multiple times, then you'd probably get a result na, mas marami pala talagang pumipili ng A over B. Okay? So, usually we mitigate this sa class by using, tawag dito, a larger sample size, or not just sensory evaluating food with using 8 people, okay? And at the same time, yung margin of error mo. Kasi kapag sa binomial tables niyan, usually naka-indicate doon yung number kung saan sobrang laki ng likelihood na hindi na due to chance yung pangyayari. Okay, suppose given the same assumptions of the expected chance of choosing product A over product B, um, what are the odds naman na at least 6 people will choose product A over product B? Okay, so which means we are now looking at here, dahil may sinabing at least, the chances of it being a 6, a 7, or an 8. So, additive yan. Yung probability for 6 choosing, 7 choosing, 8 choosing, you compute it individually and then add it up. Okay? So, that would work out to be around 55.2%. So, if you were to run this experiment 100 times na 8 people pinapili mo over product A over B and then run it 100 times, more than half of the time, you will have 6, 7, or 8 people choosing product A over product B. So obviously, in real life situations, that would mean na talagang malakas yung evidence mo na mas pinipili yung product A, no, ng majority ng tao. Alright, so you can try this one for yourself, and if you submit your solution, we could add this as bonus points to your quiz scores. So ano naman yung odds for the same context that anywhere from 2 to 5 people will choose the product? Okay, so hint lang, no, medyo similar siya dun sa last slide na solution since you're using multiple probabilities being summed up. Alright, so we can actually use or approximate the binomial probabilities using normal distribution. You just have to substitute the mu and sigma with your total number of judgments and the probability of making correct judgments by chance. Okay. Take note though that the normal approximation needs that the product of n and p is greater than 5, as well as the product of n and 1 minus p should be greater than 5. So for example, given the same conditions as before, if you want to translate this into a normal S distribution language, so we could approximate the mean to be the product of the number of responses and the probability due to chance. You get a mean of 5.6 and a standard deviation of 1.3. So, of course, dahil kailangan mo i-round up to dahil yung number of responses naman ay whole number. So, we take that to be approximately 6. So, out of, you're expecting a mean of around 5.6 or almost 6 persons out of 8 choosing product A over product B. And of course, the variability of that is based on standard deviation is 1.3. Siyempre, medyo i-round up mo na yan. So, 5.6 plus minus 1.3. That now gives us a range of around, well, 4.3 to 6.9 or about 4 to 7. So, kahit nasa angulo mo tingnan, 4 to 7 people, ang plus minus 1 standard deviation niya, talagang mas pipiliin si product A. So, yung pwesto distribution naman, okay, ang hirap i-pronounce, no? While may nasal pa kasing factor. You use it in experiments yielding numerical values of random variable x. The number of outcomes occurring in a given interval or in specified process, such as if you want to know how long a food will last, or the possibility of deviation for that, or the number of bacteria in a certain medium. So in here we have just two things we'd like to look at. Kasi yung E naman is a constant, so the X and the lambda. No? So to look at it, Say for example, we have a batch of beef cuts having 10 CFE per gram coliform on the average. We want to know in this distribution the probability that a new delivery of meat will contain uh, 8 CFU per gram coliforms. No? So in this case, your X would be 8 and your lambda would be 10. So we just input it here. We take note now when we're looking at the distribution, we want to get it as a difference of the X value and one integer lower. No? So as yung i-consider natin is yung probability lang for that value. So in this case, we're gonna get the difference of the probability for 8 versus the probability for x equals 7. Okay, and when we compute each of those and or look at the table, either ways, no, ganun din yun. We just subtract the difference of the two probabilities and you multiply that 100 to get the answer in percentage. So that would give us an 11% chance of having 11.26% chance of having a delivery which contain 8 CFU per gram of coliform. No, kasi cumulative yan, no? So, ibig sabihin dito um, yung 33.28 na yan na percent is for a summation of probability from 0 to 8. No? So, kapag ang tanong is, for example, a probability that the beef cuts will have a coliform count of 8 CFU per gram or lower, then you would use this 0.33. Pero dahil ang tanong lang is exactly for 8, then you subtract the probability of getting 7 or lower from it.